Okay. So in under week 5 in CCLE, I've posted a past midterm exam, okay, for you guys to look at and study. Of course, the actual exam will be different, but it will be similar in format in terms of I have to write some code and you tell me what R will do as far as as far as what it's going to do. Okay. So the exam will cover up through today's lecture content. Okay, so everything from day 1 until today is material that will be tested on the exam. Okay, and that's it. So on Wednesday we'll I'll cover some other stuff, but that stuff will not appear on the exam. Okay, are there any questions? Okay, no notes, no cheat sheets, nothing. Just use, you got to use your brain for the exam, okay? And some students have asked, like, why do we need to know and memorize all of these things, okay? It's important, I believe. If you are going to pursue data science, data analytics, being able to code is an expected part of the job. And it's true, a lot of the things you can look up and reference on Google. And, whether, how things work and stuff, you can reference that on Google. However, you cannot be expected, you cannot call yourself proficient, or not, I don't want to say use the word proficient, but you can't call yourself an expert or something if you got to look up everything, right? If there's 2 people, one who has internalized a lot of the stuff and is able to kind of predict how R is going to operate without having to look everything up on Google, versus somebody who has to look everything up on Google, the person who doesn't have to look things up on Google will be much faster, right? The person who doesn't have to search the internet for all of the answers is going to be much faster. And this is part of what we call becoming proficient in a language, is that you're able to start predicting and understand how the language will operate without having to look everything up yourself, okay? And certainly when it comes to debugging and identifying where something has gone wrong, it's a skill that requires being able to read and understand how the computer is functioning when it's going, okay? It's absolutely essential for debugging. Okay, well anyway, today we will cover regular expressions, okay? Text processing and regular expressions. Regular expressions is not something unique to R. This is something that appears in many programming languages, and it's even in just the Unix prompt in Bash and things like that. It's something that's very powerful and very useful, and I believe it deserves its own lecture here in our class. Here today we'll look at some of the tools within R that handle regular expressions. But if you learn regular expressions, it will be something that you can use in other languages as well. Okay. So there is a cheat sheet. Okay. There's a lot to cover in regular expressions. So if you click this, there's a little PDF cheat sheet. If I put regular expressions on the midterm exam, which I probably will, I will include this PDF cheat sheet, okay? So you have to become familiar enough with regular expressions to be able to read and understand the cheat sheet, but you don't have to memorize every single, special character that appears. That will appear on the cheat sheet, but you have to become familiar enough with how the regular expressions work. Okay. There's the stringr package was written by Hadley Wickham, to which we are so thankful for everything he's done for R. And he's written a vignette on how the stringr package works. There's also a website called regexer for regular expressions that allow you to kind of test out regular expressions within your browser, which is quite a handy feature as well. Okay. As far as today's lecture goes, we're going to cover basic ASCII ICU regex. There's a lot of different flavors. ASCII is kind of how the English language handles text and stuff. But of course, if you're doing anything in Unicode and things like that, things will be a little bit different. But this is just the basics. Okay. We'll use package stringr. Okay, library stringr. R does have some native capabilities, but I do believe stringr has made handling regular expressions much better. Okay. All right. Here are the functions that we will primarily use. There's string detect. This will either return a true or false if it finds. So all of these things, you give it some string and you give it a pattern to match. And string detect will return true or false if it finds that pattern matches something inside the string. Locate will give the text location. It'll say this match begins at the fourth string or fourth character or something like that. Okay, so this will return a position. Probably the ones you will use the most will be extract and match. Okay, extract will pull out text that matches your pattern, and match will, if you listed capture groups, it will extract out the pattern along with separate out the capture groups, which we'll talk about there. Okay, and then string split will have will split up your string into smaller pieces. Okay, and all of these things have a underscore all version. So there's string detect all, string locate all, string extract all, and match all, and things like that. So let's talk here. Okay, there's a comic that I thought was kind of cute from XKCD. All right, I don't know if you guys can read it. I'll read it to you. Okay, so it says whenever I learn a new school, I concoct an elaborate fantasy scenario where it lets me save the day. And the scenario goes, oh no, the killer must have followed her on vacation, but to find them, we'd have to search through 200 megabytes of emails looking for something formatted like an address. It's hopeless. And then our hero swings in. Everybody stand back. I know regular expressions. Swings in, uses regular expressions, and they say, hooray, and he swings away. Okay. An unlikely scenario for us, but it is true. Regular expressions do allow us to do something like process through a whole bunch of text that's formatted in a certain way and search for something that we need to find. Okay, and it's quite powerful in that way. Okay, so basically what regular expressions do is, like, if you've ever written a document on Word, you've probably used the find, maybe even the find and replace function in Word, right? And you'd say, like, I need to find all instances of the word California, or something like that. But you might have become frustrated in Word if there's something that you want to find, like, let's say you wanted to find also instances of CA, because that's how people abbreviate California. Maybe if they're not from the state of California, they might abbreviate it as Cali, which us natives would denounce. But anyway, you might want to say, let's search for CA or California or things like that. And there's not it's not an easy thing to do within Word. You have to kind of run separate searches. Whereas regular expressions allow us to find things based on patterns, okay? But first off, we're going to just start with simple matching. This is kind of the way Word or your browser, if you say find the set of characters or something, it's gonna do this, okay? So here I have a vector of strings that say this is a simple vector of words. In string detect, we say find this, okay? And it's going to say THIS, it matches the first thing, it returns true for that one, false for everything else. We say find the characters IS, and it finds it in this and is. It finds both of those, it returns false for everything else. We say find the characters OR, and it's going to highlight OR in vector and OR in words, and it finds it true and true in these two spots here. Okay, so this is just regular searching for some kind of character string. Okay. But the thing that makes regular expressions so powerful is that you are not limited to just finding these literal character matches. And there's a bunch of stuff called meta-characters that allow us to find, I guess, sets of characters and patterns to match, not just literally the letters OR or things like that, okay? And these are the symbols that define the meta-characters. We've got the dot, the caret, the dollar, the star, the plus, the question, and all of these braces and brackets and stuff. And so if you wanted to find the literal square brace, okay, you have to, what we call, escape that character. You have to say, when you write a pattern, you would use the square brace and it takes on its special meaning, okay? But if you want to say, I'm actually looking for the square brace itself, you have to say, search for slash, you have to say slash square brace, okay? But because slash itself is an escape character, at least in R, you have to use double slash square brace, okay? And so this will say, I am searching for the actual character square brace, okay? It's kind of like if you're trying to communicate, a password into to somebody. You have to say, like, I'm talking about the numeral 1 versus the word ONE or something like that, right? Okay. Anyway, so some of the things we can use are called anchors. Okay, and this will tell R that the regular expression processor that the string we're looking for is located either at the start of the string, the end of the string, or at a word boundary or not a word boundary, okay? Word boundary is little b / little b, and non-word boundary is /capital B. We're gonna see a bunch of things, and a lot of times it will be / some kind of letter, and it'll be the lowercase letter will be that thing, and then the capital of the same letter will be not that thing, okay? So it's very case sensitive. So /little b is word boundary, B for boundary, and /capital B is not word boundary. And I'll explain what a word boundary is in just a moment, okay? But you'll see things like that for /little s versus /capital S. But anyway, we've got caret and $ for start or end of the string. So here I've got the text. The quick brown fox jumps over the lazy dog, dog. I purposely put dog in there twice, okay? And here I can say, replace all instances of the character match THE with a dash, okay? So here, this is much like the way Word would run, and it replaces the word the here at the beginning and the word the for the lazy dog. Those both get replaced with a dash, okay? Now I say, when you search for the characters THE, it needs to be at the start of the string, okay? So here, it only replaces the at the start of the string. It recognizes this at the start of the string, and it replaces THE with a dash. This the is untouched because it's not at the start of the string, okay? /cap A is identical to using the caret here, okay? So these two things are identical, and so it does the exact same thing, okay? If I say the $, it means the string has to end with the. It's going to be the at the end of the string, and there's no match there, okay? Because the string ends with dog. There's no match for the $, okay? The end of string. Okay, over here, if I say replace dog with dash, it's going to replace both instances of dog. We've got lazy, dog gets replaced with dash, and dog gets replaced with dash, so it goes lazy dash dash. And here, if I say replace dog $, it's only going to replace the dog that ends the string, okay? So it's going to only replace this one, okay? Is that okay? As far as start and end of string anchors, okay? Caret and $, or /big A and /big Z. And anytime I say, I guess I should say \big A, but anytime I'm saying backslash, in R, we have to use double backslash. Okay, here I've got the text says words, jump, jumping, umpire, pump, umpteenth, and lumps, okay? And so here if I say replace all and search the text, search for the pattern UMP, replace it with a dash, Okay, it replaces all these. It replaces the and jump, and jumping, umpire, pump, umpteenth, and lumps. All of those instances of UMP get replaced with a dash. Okay, and here I demonstrate how word boundaries work. So I've got \b for word boundary UMP. Okay, so this means we're searching for UMP, but it needs to be preceded by a word boundary. A word boundary is basically a space in front of a word, or it appears at the start of the string, things like that. Those count as word boundaries, or end of the string is a word boundary, or punctuation mark. Okay, except it does not include the space. So if it's like space umpire, okay, the word boundary is before umpire, but doesn't actually include the space here. Okay, so word boundary UMP will replace the UMP in umpire and umpteenth. Okay, and nothing else. Okay, jump. The J is not a word boundary. There's no word boundary there, so those do not get replaced. Is that okay? How the word boundary works? All right, and here I have \big B, okay, which means non-word boundary, and so it's going to replace the and jump, and jumping, and pump, and lumps, because those are cases where there's not a word boundary UMP. Okay, umpire and umpteenth do have a word boundary in front of it, so they do not match this pattern. Okay, here I got ump followed by a word boundary, so this will only replace basically words that end with ump, so jump and pump, but neither jumping, umpire, umpteenth, or lumps will match. Okay, and this down here, \big B will be words that, UMP, but not followed by a word boundary, so that will be, so jump ends with a word boundary, so it doesn't match, but the and jumping and umpire and umpteenth and lumps do match. Okay, so those count. Is that all right for word boundaries? Is there a question? A double backslash, because the slash itself, backslash, is as a special character in R, and so in R we have to use a double backslash. In most other regular expression languages, you only use a single backslash, but for us, we have to use a double backslash. Yeah. So just get accustomed to doubling your backslashes for R, but other places you'll just use a single backslash. Okay. So yeah. So here I'm doing kind of just single backslashes, but just when we put it into R, everything appears with a double backslash. Okay. All right, so we've got character classes. We have S for little s for white space character, and that includes both a breaking and non-breaking space, and a cap S for anything that's not a white space character. Okay, little d for digit, big D for not a digit, little w for a word character. Word characters are basically your letters A through Z. Caps are little. The digits 0 through 9, also underscore, count as word characters. Okay, cap W for not a word character. And then you have the dot, which is basically any character except a new line character. Okay, so the dot is basically any character there. I'm not sure if you guys are familiar with breaking and non-breaking spaces. It does appear in your homework, although it's in the section that I've kind of taken care of for you. But the idea behind a breaking and non-breaking space is, let me see. Let me open up Word. All right, so, and I can write something like, I live in the city of Los Angeles, okay? Now, as you write stuff, you can say, hello, comma, space. When the word processor recognizes that, here's the margin right here, okay? There's a margin right here on the page, and when it recognizes that the word is not going to fit in the margin, it pushes the entire word down onto the next line, right? Okay, and this is not anything anything impressive, you know, you can say, hello, my name is Miles, and I live in the city of Los Angeles. And as I write these things, or as I delete these things, it pushes the words one at a time, right? Now, somebody might say, Los Angeles is a proper noun, and it is improper for Los to appear on one line and Angeles to appear on the second line, right? We might say they need to stay together, okay? So normally, every space, if I turn on special characters here, okay, this will say every space appears like this with these little dots, okay? We can create something called a non-breaking space. So one way you can keep Los Angeles together is not to put the word, not to put a space there, right? And I can write hello, and when I do that, it moves both Los Angeles together. Or another option is to use an underscore, okay? And if I do that, then that will keep it together, right? Hello. But you might say, well, that looks ugly. I need to keep them together, but I don't want a thing. You can use something called a non-breaking space, okay? Command-Shift or Control-Shift space inserts this special space character, which to regular eyes looks exactly the same, but when you turn on secret characters, you see that, oh, this is a different kind of space, okay? And so this basically has the effect of using an invisible underscore. And so if I say hello, and I put in the comma, it's going to push both. It's not going to separate the Los and the Angeles. It keeps them together. It's what we call a non-breaking space, because part of us might say it is wrong to separate these two words for the city of Los Angeles. We need to keep them together, okay? So we have something called a non-breaking space. It makes an appearance in your homework when you extract the team names, like the Arizona Diamondbacks or something like that. There's a non-breaking space between Arizona and Diamondbacks, okay? And it's invisible when you download the thing, but the computer recognizes the difference there. And so it's in this section that says a little bit of text cleanup. I do some basic processing work to replace the breaking spaces with regular spaces, okay? But anyway, /s will match both kinds, okay? And again, here we see the how the little s and the big S separate between the thing versus not the thing, okay? Capitals will be not that thing, okay? So space or not space, digit, not digit, word character, not word character. We also have quantifiers, and the quantifiers will allow you to say, I want, more than one of these things. So each of these will match just one space or one digit or one word character. But you can say, I want 0 or more, or I want 1 or more with the plus. And you got question mark for 0 or 1 of those things. And you can also use curly braces to say, I want a specific number. Okay, you can say curly brace 3 for exactly 3 of those characters, 3 comma, curly brace 3 comma for 3 or more, 3 comma 5 for 3, 4 or 5, 3 to 5 of those characters. Okay. The star and the plus are both greedy. Okay, and I'll talk about what it means to be greedy. So here, my texts say words or numbers 9, 876 and combos 1, 2, 3, like password underscore 1, 2, 3, 4. Okay, and here I can say replace everything that is what? A space character with a dash. Okay, so it goes through and it finds each single space character, and each single space character it replaces with a dash. Okay, so we get pretty much the same thing. The spaces have all been replaced with dashes. Here I say \big S for everything that's not a space character, and replace them one at a time with a dash. So we get dash, 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 dash for words, dash, dash for or, and a bunch of dashes for numbers. Everything that's not a space character gets replaced with a dash. Okay, over here, I say replace \big S plus. So this will say non-space character, the plus says 1 or more. Okay, 1 or more says, okay, WORDS, those are all non-space characters, and they match this pattern of 1 or more non-space characters. We're going to replace that with a single dash, okay? Then it encounters the space, and then or gets replaced with a dash, space is a space, numbers gets replaced with a dash, and then 9,876 gets replaced with a dash, things like that, okay? This is different. A non-space character is different from a word character, okay? This is backslash little w, okay? And the difference here is that the comma is a non-space character, so 9,876 entirely matches this pattern and gets replaced with a single dash, okay? So there's going to be 8 dashes here, whereas this word character will match the 9 but not the comma. So the 9 gets replaced with a dash, the comma does not, the 876 gets replaced with a dash, okay? And so here we have 4 dashes, comma, and 5 dashes, okay? And spaces, okay? Dash, space, dash, comma, dash, space, dash. Is that okay? The distinction here? All right, and how the plus modifier will kind of say everything here matches and groups them together. Here I've got replace digits /d with a dash, okay? So the 9 gets replaced, the 876 gets replaced, okay? And this says 1 digit at a time, okay? /little d is 1 digit character at a time. And so each digit gets replaced with a dash, okay? Here this says everything that's not a digit, okay? And that replaces everything but the digits. The comma gets replaced with a dash as well, okay? Here this says 1 or more digit characters, okay? /d, \d plus. So the 9 gets replaced with a dash, and the 876 is a single match, and that gets replaced with a dash, okay? Combos 1, 2, 3, 1, 2, 3 will match, and underscore 1, 2, the 1, 2, 3, 4, and password underscore 1, 2, 3, 4 is a match, and that gets replaced as well. And then here we have a non-digit character, 1 or more non-digit characters, and that's going to basically replace, non-digit character will be everything from words or numbers, space, okay, will replace up to here, gets replaced with a single dash. Okay, the comma gets replaced with a single dash. And here we're just left with the digits. All right. Is that okay? And then here we can see the difference between word characters and non-word characters. So the word characters will replace everything, okay, other than spaces and punctuation, okay? And so basically, and the only punctuation it will replace will be the underscore. So password underscore 1, 2, 3, 4 gets all replaced with dashes. Here, this is non-word characters, so everything that's not a word character gets replaced, which means all the spaces and the comma will get replaced. And here I have 1 or more continuous word characters, /w plus, \w plus, so that replaces that. And then here is, this ends up being the same as this because we don't have any actual, I didn't put any like 2 spaces in a row, okay? But this would say, you know, 1 or more continuous non-word characters. All right. Is that okay? This is interesting, okay? So here I've got \d question mark. So this says match 0 or more digit characters and replace the match of 0, I'm sorry, not 0 or more, 0 or 1 digit character and replace the match of 0 or 1 with a dash, okay? And so it starts at the beginning of the string and it says, oh, I found 0 digits before the T. And so it puts in a dash there, okay? And it says, I found 0 digits between the T and the H, and it puts a dash there, okay? And so we get this weird thing going on, okay? But it also finds a digit for 1996 and replaces each of those with a dash. And I'm not sure if the extra dash is either from before or after the match, okay? But it replaces each of those things, okay? Here I have \d curly brace 3, which means, and the thing reads from left to right, and it says, find 3-digit characters and replace 3-digit characters with a dash, okay? So here it finds 199 and replaces that with a dash, and it leaves the 6 alone. Okay, 310 gets replaced with a dash. Combo 123 gets replaced with a dash. Password 1234, the 123 as it's reading left to right will match, and that gets replaced with a dash, but it leaves a 4. Okay, and single digit 5 does not get replaced. Okay, over here we say 2 or 4 characters, 2, 3, or 4, and so 1996 gets replaced with a dash. 310 gets replaced with a dash because that counts as 3 characters. Combo 123 matches, and password 1234, the 1234 counts as a match of 4 characters, and that gets replaced with a dash. Okay. Is that all right? Okay. I have a lot of examples. There's a lot that we're covering here, okay? And the best way to kind of become familiar with regular expressions is to kind of just play around with them, right? Write up some strings and see, like, play around with the things and see what can work, okay? Here, we can also specify ranges of characters, okay? And so I've got, if you use a square brace, this will say match one of the letters A or E or I or O or U, okay? So this thing will match just one letter at a time, okay? And here, if you put a caret in a square brace along with letters, it will say match one character that is not A, E, I, or U, or something like that, okay? So you can just put in a bunch of characters in here and it will match any one of those, one character at a time. You can specify a range like A through Q, or capital A through capital Q. If you want to match all 26 ASCII letters, you can use little a to Z, capital A to Z, okay? And this will match all the letters, because /W will match all word characters, which include digits and underscores. But if you just want letters, you can specify this, all right? And this works just for, you know, English alphabet ASCII letters. If you're dealing with foreign languages and stuff like that, you probably need to use something a little bit better than this, but I'll leave that up to you to look that up, okay, when you encounter stuff like that. There's, again, different flavors of regular expressions that handle other things. And then if you want to just specify a range of digits, you can say like digits 0 to 7 or something like that. Otherwise, if you want all digits 0 through 9, just use \D. Okay, so here I've got, I wrote the year 1996, area code 310, combo 123, password 1234, single digit 5, okay? And here my pattern to match is going to be bracket YEAR bracket, okay? And if I say extract, it's going to find the first character that matches anything in this range, okay? Which technically is the E in the. Okay, so when I say string extract match the first thing, it's going to pull out the E and the, and we get this. Okay, and it extracts out the first thing, E. If I say replace all text in this pattern with this that matches this pattern with a dash, it's going to replace the E in the YEAR, because in year, those all match. Also for area code, A, R, E, and A all match as single characters that match what appears in here, okay? And also the E in code and the A and the R in password and the E in single digit, those all get replaced with dashes, okay? Here I can say find anything that matches a Y or an E or an A or an R, but I want one or more of those, okay? So it replaces E in the, and then the continuous YEAR match, each of those letters match this, and so that entire thing gets replaced with a dash. Same thing with area. Area gets matched with this, and that gets replaced with a dash, okay? And so still also the A and the R and password and things like that also match, so those get replaced, okay? If we're annoyed that these single letters are being matched, we can use something like this. You know, match one of the letters Y, E, A, or R, and I want two or more, okay? And that will match year and area because those match as characters that match Y, E, A, and R, continuous two or more of those things. Okay. Is that okay? All right. We have groups. Groups are incredibly powerful and allow us to kind of group searches and extract out, or what we call capture, the groups, okay? So here I just have a literal pattern, A, B, C, and D, but I've put parentheses around the B and the C, okay? Which means it's going to match this literal pattern of A, B, C, D, but it's going to, what we call, capture the text that's inside the parentheses. In this case, it's going to be the literal letters B and C, okay? If you want to use a group but not capture it, you throw in this question mark colon, okay? For whatever reason, that's how we specify. I need to use a group, but I don't actually want to capture it. You use question mark colon, and that forms a non-capturing group, okay? You can use multiple groups. So here, this will match A, B, C, D, E, F, G, H, I, literal characters, and it will pull out both groups, A, B, C, and G, H, I, okay? Grouping is useful, especially if you're going to use the OR operator, okay? So if you have the OR operator, which is a vertical bar, you can say, I want to match MRS or MS or MR, okay? And it will match anything of those things, okay? That, one of these patterns. And then if you use a capture group and you're going to do something with replace or something, you can reference which groups get captured by using \1 or \2 and things like that, okay? Numbered for each captured group. All right, this is a lot. Let's, I think the examples will help clear this up. Okay, so I have the text that says, Mr. Smith, Mrs. Mr.Smith, comma, Mrs.Lee, comma, Ms.Garcia, okay? And here the pattern is MRS or MS or MR in a capture group, okay? And so it's going to go through and it's going to match anything, all instances that match this text, okay? So here it matches MR, it matches MRS, it matches MS, okay? And because this also formed a capture group, it's going to extract that out, okay? When you use the OR operator, it gives preference to the first thing that appears in the OR operator as it reads left to right, okay? So here I have almost the exact same capture group, but I wrote it out as MR, vertical bar, MRS, vertical bar, MS, okay? So if I write it this way, MR is going to, because it's written first, is given preference as it searches left to right, okay? So what happens is it's gonna find Mr. Smith, it's gonna say MR, great, it finds a match there. Here we have MRS.Lee, okay? And it finds the MR in MRS and it says, I'm done, I found a match, and it gives preference to that, okay? Which is not what we want, right? We probably are trying to extract out the titles and we want the misses, the MRS, and here it's pulling out the MR because it's giving preference in the order that's specified here, okay? And then the MS, that works fine there. Yes, question?
Why is it coming out as a matrix?
It's actually coming out as a list of a matrix, a list containing a matrix. And that's because I said match all. So match all says, within the string, we might find this pattern match multiple times, which it does, okay? This pattern matches 3 times, and each match gets its own row. Because the capture group, I think on the next example you'll see, you can have more than one capture group within a pattern, okay? So when you say match all, it's going to find all instances of the match, and then it's going to extract out the capture groups, okay? All right. Over here, this is maybe a little bit better, maybe not, okay, depending on what we're trying to do. So here I have M, R question mark, S question mark, okay? So this will say match a capital M and then an R, 0 or 1 M's, 0 or 1 R's, along with 0 or 1 S's, okay? Which means it will match MR because we have an M and 1 R. It will match MRS, we have an M, 1 R, and 1 S. And it will match MS, which is M, 0 R's, and 1 S. So if I use the question mark, which basically says 0 or 1, you can think of the question mark as a maybe, right? We're gonna find an M, an R maybe, and an S maybe, okay? And then it will match, okay? The only problem, what's the problem with this? Is there a problem with pulling out titles with this? What else will it match other than MR, MRS, and MS? It will also match just M, okay? And so if you have I don't know, Mr. Mason or something like that, it will match just the capital M in Mason. Okay, so that's an issue. Okay. All right. So here's an example why it's returning a matrix. All right. So over here I got the same thing. I put Mr. Smith, Mrs. Lee, Ms. Garcia, and Smith Road. And here we're saying I want to match one of the titles, MRS, MS, MR, followed by, what's this? / dot. Okay, / dot is the literal dot, not the wildcard. Not dot is the wildcard character, which will match anything. But here I'm saying I want to match a literal dot. Okay, along with a space, and then a word character, and I want one or more. Okay, and one or more word characters is put into a capture group, which means we want to extract that out. Okay, so it's going to say, all right, what match is this? Okay, and so it says Mr. Smith is a match, followed by Mrs. Lee, that's a match. Ms. Garcia is a match. Smith Road is not a match because this first part does not match MR, MS, or MR, anything like that. So this is not a match. Okay, because I have two sets of parentheses here, it pulls out both capture groups. It pulls out the Miss MR, it pulls out the one or more word characters, Smith. It pulls out the MRS, the one or more word characters, Lee. It pulls out the MS, and one or more word characters, Garcia. Okay, and so here it finds all three matches. Each match, entire pattern match, gets its own row. The capture groups get additional columns. Okay, and that's why we need a matrix. Over here, it's the exact same thing, except I just put in the question mark colon, which says, you know, I need to use this capturing group thing, or I mean this grouping mechanism, but I do not actually care. I do not actually want to capture this or extract this out. So it pulls out the same, it finds the same matches, Mr. Smith, Mrs. Lee, Ms. Garcia. It does not match Smith Road. And then the only thing that it extracts out of there for capture groups will be the one or more word characters, which is Smith, Lee, and Garcia. Okay, it does not actually capture the title, MRS, MS, or MR. Yes, question?
So is the first column like the patching key?
Yeah, so the first column is the entire set of characters that match the pattern. Okay, so the set of characters that match the pattern will be the first column. The second column will be the first capture group, and then the one after that will be the second capture group, or however many capture groups you have. Yeah.
So it knows that it's separated by comma.
It doesn't know that it's separated by comma. It's just searching left to right for things that match this pattern. So it's going to say, all right, do I find something that matches one of MRS, MS, or MR? Yes. Followed by a period? Yes. Followed by a space? Yes. Followed by one or more word characters? Yes. And it ends at the H because the comma is no longer a word character and it stops. And then it keeps going. It says, well, this comma doesn't match anything. The space doesn't match anything. Oh, look, MRS, that starts to match, and it opens up another pattern. It keeps going. It ends at the E and says that is the end of the pattern that matches. Okay, and that's what it's pulling out. And then this thing that says Smith Road, this doesn't match anything. Okay, it's just there. All right, here's an example of using the capture groups and the references back to them using the \1 or \2. Okay, so here I've got George Washington, comma, John Adams, comma, Thomas Jefferson, okay? And here the pattern is one or more word characters, a space, and one or more word characters. And those word characters are matched with, are grouped, they are captured groups. And then we say that might be followed by a comma, maybe, okay? Comma question mark means zero, comma might appear 0 or 1 times, okay? So this will match George Washington and the comma, John Adams and the comma. It also matches Thomas Jefferson without a comma, okay? If I didn't put the comma in there, okay, if I did not put the if I did not put the question mark in there, then it would match George Washington and John Adams with the comma, but not Thomas Jefferson because he doesn't have a comma. Okay, so I have to put the question mark in there in order to match. Okay. Okay, and so the match all will say these are the things: George Washington, comma, I pulled out George, I pulled out Washington, John Adams. The capture groups are John and Adams, and the capture group here is Thomas and Jefferson. And if I ran a replace and I say find the pattern match, okay, in this case George Washington, comma, replace it with the second capture group, comma, space, first capture group, semicolon, okay? So what it's going to do is it says, well, I found George Washington, comma, I'm going to replace this entire match with second capture group Washington, comma, space, first capture group George, semicolon. Then the second thing that matches was John Adams, comma, it replaces it with Adams, comma, John, semicolon. And the third thing that matched was Thomas Jefferson, and that gets replaced with Jefferson, comma, Thomas, semicolon there, okay? So you can kind of reference back to the things that you captured in the capture groups and reuse them again if you're in some kind of replace operator, okay? Which is pretty cool in my opinion, okay. Here's just some more examples of matching stuff. I gotta hurry on here, okay? And I might just go like 1 minute over, and I apologize. Okay, so greedy versus ungreedy matching, okay? The star will say 0 or more, okay? And so here if I have a capital P dot star R, it's gonna go left to right, and it's gonna try to find as much as it can that matches. So it starts with the capital P in Peter. So it got Peter Piper picked a peck of pickled peppers. It starts with the capital P here and goes all the way up to the R in pepper, okay? If I do capital P dot star question mark makes it ungreedy, okay? Ungreedy will say start at P going left to right, keep going until the pattern ends, okay? And so here it gets Peter, it finds the R and R for Peter, and it ends there. Here, if I say extract all, it starts the P, capital P here, it goes until it ends R, Piper, capital P there, it keeps going until it ends with the R there, okay? There's another example that you can look at. I'm gonna kind of skip through here. I just wanna demo how powerful this is, okay? So if I come to the campus directory here at UCLA and I say, let's search for the statistics directory, okay? It pulls all of this out, and there's a whole bunch of information when you click on it. Stuff like all of this information, but it's not easily accessible, okay? Like we have the administration contact, we have the chair contact, his name, and all of that stuff is in here, but it's not easily accessible. Selector gadget doesn't work very well. If I do view page source, there's all of this text, okay? But the information is all embedded in here, okay? It says stuff like department statistics, all of this, except there's all of these HTML tags, okay? So just real quick, all I did was I just saved all of this HTML text. I stored it in this file that says regex HTML directory.txt. I wrote this crazy regex pattern, okay? Which maybe is hard to translate right now, but basically, just using a regular expression, I'm able to extract out all of the information from that website, okay? In a way that's a lot more processable and manageable. It pulls out each thing, department, statistics, all of this stuff out just with regular expression. It's incredibly powerful, incredibly useful if you can master all this. Okay, we'll end here for today, and we'll see you guys on Wednesday.